So next thing we're going to learn now that is going to be linked list. So we're going to see what is linked list, types of linked list advantages, linked list operations, two pointers, sliding windows, different topics we're going to learn about. So first is linked list. So a linked list is a collection of elements and it's a linear data structure, and those elements are called as nodes. So each node contains a link to its successor node. What does this mean? It means one node is going to have data and successor of the next node. It means the reference of the next node is stored in the previous node. So you can traverse the linked list in either directions starting at any given node. So used to implement a queue, stack, data structure, and lots of other problems are solved. So if you can see over here, this is called as a node. So 20 is the data and this is called as a link, or you can say reference. So link is what? The reference of 30 is stored here. It means the 30 you can access from this 20, this node, that 30. So 30's reference is stored here. All right, now 30 node is this one is data, 30 is data, and this is the link or reference of 56. And last node has, when we understand that last node is going to have null, so it's going to its next, that is reference, is going to be null. So that is also called as the tail of the linked list, and first one is called as the head of the linked list. So we're going to see each and everything operations, that time you'll understand better. So linked list operations. So what are the operations there? So we're going to see traversal in a linked list, that is accessing elements of the linked list. When you do insertion, so add elements to the linked list. But when you say add elements to the linked list, that actually means you want to add the element at the head, you want to enter in the middle, or you want to enter in the tail of the linked list. What I'm saying, we'll understand one by one each things in the whiteboard. So next is deletion. Same thing is going to happen here. Deletion means removing existing elements. Similarly, we can delete from the head, we can delete from the middle, and we can delete from the last. Searching of a linked list means you want to search the node if it is there or not. Either you can search by the key or you can search by the position. So you can create a counter variable, and that way you can do. So you can sort the linked list also. That's all are done. Now what is the advantage of linked list? So it's a dynamic size is there. So linked list nodes can be linked or unlinked to control its size even at the runtime. So here in the runtime you can change the size. So it's allocated in the heap memory. So memory consumption, when you say a linked list store elements in a non-contiguous fashion, that enables you to store elements when you run out of contiguous memory. It means it is not necessary that in case of array we did that it has to be next index we have to enter the value, but here it is not. Wherever it gets the space in the heap, there it linked to it and linked list is formed. Next is fast insertion and deletion. So the insertion and deletion in a linked list is in constant time, that is O of 1. A linked list node can be easily inserted or removed without reallocating memory or moving any other data. So this is because each node contains a reference to the next node, right? So what are the disadvantages of a linked list? So the disadvantage of linked list is it is more difficult to traverse than array. So this is because you need to keep track of the head node as well as the current node in order to access the next node. Now what are the types of linked lists there? So there are basically three types of linked lists: circular linked list, doubly linked list, and single linked list. Three linked lists are there. So we're going to talk about this three linked lists one in detail. So I'll give some overview of the three, and we will be jumping over the single linked list in detail, and we'll do the implementation. So single linked list, it is the most basic type of linked list. Each node in this list contains a data element and a reference to the next node. So it allows traversal in only one direction, from head to the tail, that is the last node. Single linked list is implemented using the linked list class in Java. So linked list can be implemented by linked list class or we can write it, we can define the functions on our own. So we're going to do the both thing. So first thing we're going to learn, that is the singly linked list. Every node contains two fields, data fields and a pointer to the next node. The most common used linked list is move only in one direction, a collection of an ordered set of element. So here you can see this is a singly linked list. One node is there and this thing is going to be done. So now we jump to the VS Code and we'll talk about linked lists in detail here. All right, so let's take it and try to understand each and everything about the linked list. So first thing is, so what is the difference between array and a linked list? All right, so array is a data structure where it is a continuous memory allocation that like if first address is 1024, then second address has to be 1028 if it is an integer array, then third address has to be 1032 and fourth address has to be 1036. But this is not the case with the linked list. It means the address of the nodes. So here in linked list we say nodes, that you already know because I talked about in the PPT that here we call as a node. So those node have different memory. It may be 100, that next memory may be 500, next memory may be 700 and next memory may be 50. Now what actually happens is this 500 reference is stored over here, this 700 reference is stored over here, this 50 reference is stored over here. It means from this node, four node, if I say 4 node here, this one as name as the 4th node, so from here you can access 5 because the reference of 5 is stored over here. You can see, right? This is what our node is. So we're going to talk about that, how, like what node consists of. Node is going to be consist of data and node is going to consist of what? Next reference. So it's going to store the reference of the next node. So this is as a whole, this whole is called as a node. All right, so this is all about it. Now what is the difference between a array and a linked list? Okay, the size of the array is fixed, but in linked list we do not define the size. It means we can, if you remember in array when we learned that array size cannot be changed in the runtime. So because array is a static, but we can change the size of the linked list in the runtime that we studied. Now thing is, we going to see that insertion in an array and deletion was O of 1 in the array, because we have to shift either to the right side or to the left side, if you remember. But in linked list, its insertion and deletion complexity is constant, that is O of 1, and accessing element in array was through the index, so it is O of 1, but accessing elements in linked list is O of n. So these are the differences between linked list and array. Now ease of use, if I say, then obviously array is easy to use, but linked list is not also hard. All right, so linked list is a linear data structure which is a collection of nodes. Now why we say collection of nodes? Because it's, suppose let's say I want to take this one node I've created, one node I created, another node I created, another node I created, another node I created. So here this is connected to this, this is connected to this, this is connected to this. How this is connected? Each node is divided into 2 parts, right? And a last node is will be pointing to null. All right, so each node, this is the next, this is the next of all node, this is next, this is next, and this is next. Okay, it means it's a reference, is going to store the reference of the next node. All right, and here we have the data, here we have data, here we have data, and here we have data. All right, so here from here you can see that it is consisting data and next node address, next node reference. So this is node 1, this is node 2. So this first node is called as the head node. This first node is called as the head node, and last node is called as the tail node. Okay, in case of implementation, if you don't take tail node also, that is completely fine, but we can solve this, we can implement this linked list in two ways. Either we take only head node, or we take head node as well as the tail node. So those are the two different implementations that can be done using linked list. So we're going to see, when we're going to jump to the VS Code, we'll see and we'll try to do each and everything. All right, so let's see, how insertion is done in a linked list, and we're going to see how deletion is done and how searching is going to be done, and we're going to jump to the VS Code and understand better. Okay, so we're going to learn first, that is the singly linked list. We're going to keep right now, we're going to do singly linked list. After that, we're going to go to the doubly linked list and circular linked list. For now, just keep focus on the singly linked list. Okay, so what I said, the first node is called the head node. Suppose this is the node is out there, and when I say insertion in linked list, so when I say insertion in linked list, it means insert at head. Second is insert at tail or last, and insert at middle. Okay, what does this means? It's not simply like that in array that you insert at the last. No. So in linked list we can insert in three ways. That insert at head means, suppose one node is already there, so insert at head means it's going to come at the first position, this position. So that is what insert at head is called. So this is one separate node. All right, this is separate node. So what I have to do is, I have to store the reference of, let's say reference of is 500, so I have to store 500 here to link it. So it is right now null, so it will be linking like this. So this is called insert at head. Now if I want to say insert at tail, it means what? At the last position of 10. So if I print this linked list, it will be printing 12 and 10. So this is insert at head. Now if I want to, one linked list is there, that is one node is there, that is 10, and I want to insert at tail, it means I want to insert at this position. So this is insert at tail. Now what I have to do is insert at head and insert at tail. So what we need to do is, actually we keep the head. So let's say this is the head, it's already there, 10. Let's suppose this 10 is there and this is head, and I want to insert at tail. Let's suppose I want to insert this at the tail. So what I have to do, so what I have to do is, this is pointing to null, this is going to be pointing, because tail node is always going to point to the null. It means that is the last node of the linked list. That is the indication, right? Now if I want to insert at tail, it means I have to insert at the last. It means this reference of 600 I have to store over here. So 600 need to be stored here. From null, it will be changing to, it going to point it to here, right? So this is called as insert at tail. All right, now insert at head is done, insert at tail is done. Now I'm going to see insert at the middle. Now if we want to insert element at the middle of the linked list, suppose let's say this one linked list is there. Okay, now I want to insert at this position. I want to insert it, that is this position. So what I have to do is, I'll create a node, that's node to insert, and what I'll do is I will link. So this is right now linking this, 700 stored is over here, right? If it is the reference of 6, then it is stored over here. Now what I have to do is, I have to store a 700 over here, and what I have to do is 800 will be stored over here. Then only we can link it. It means we want to connect this line and we want to connect this line here. This way we can insert. So you can see 4, 5, 3, 6, 7 inserted at the position. This is how insertion work in a linked list. Now suppose Same now if I talk about deletion. So deletion also happened from head, deletion also happened from tail, and deletion also happened from the middle position. Now question is how to delete it. Now if I want to delete, let's say, this element from the linked list, so what I have to do is I have to take out of it and I have to point it to null. It means this node will not be storing this 500 address, right? That way we can delete it. Suppose I want, okay, here is talking about last node. Okay, let's talk about the last node first, not first node. So last node it is talking about, it means it wants to delete this element and it is already pointing to null. It is already pointing to null. So what I'm going to do is, but this is storing, this 50 has been stored here. So what I have to do is I have to point this to null, right? And this is already pointing to null, so it gets detached and it's over. So this is how you delete from the last node. Suppose you want to delete from the first node. So what I have to do is, if you see here, suppose this is need to be deleted. Okay, this is connected here. I have to remove this connection. It means I have to remove this 500 reference from here. So what I have to do is I'll take out this node and I'll point it to null. I point it to null. If you can see, so it got detached and this is separate, right? Last node is always going to be pointed to null because we're going to create constructor and I'm going to say that we need to create this node and we have to say what that node has. The node has going to be data and the node has going to be the next reference. That is what is going to be there. Okay, now this is all about if you want to delete from the first. Now if I want to delete from the middle, let's say I want to delete this 6 element from here. Let's say I want to delete this 6 element from here. So what I have to do, here you can see 2 connections is there, right? So what I have to do is I'll take this connection, I'll put it this way. I'll take this connection and put it this way, and I'll take out of this node, I'll take out this node and I'll be pointing not 50, I'll be pointing it to null. So this is how it's going to be delinked. It means I have to store 50 over here and it's going to be connected over this one. So this is deletion from the middle. Now we're going to jump to the VS Code and where we're going to see tons of, how to count it, how to, traverse it, how to create the node, how to use the constructor, how to initialize the variables, what type of things we will take, each and everything I'll be talking in detail, and I'll comment the code also, so that in future if you try to see this and then you can directly understand by the code, you don't have to see the video. So let's jump to the VS Code and try to understand each thing one by one and implement the single linked list one by one in detail. So thank you.